All right, hi you guys. I'm so sorry that I can't be there today. Today we're going to be looking again at point slope form, just like yesterday. So in class yesterday, we learned how to graph equations. Today we're going to be focusing on writing equations. So we're going to look at basically three different types of problems. The first is a pretty easy one. If I give you the slope and a point, can you write an equation of the graph? So that's going to be the first part of today's lesson. Then we're going to be looking at problems where if I give you 2 points, can you find the slope of the 2 points using what we've learned in the past, and then transfer the equation over. And the third one is if I give you a table without the y-intercept in it, can you write the equation? So we're going to start with the easy stuff, which is writing an equation in point-slope form. So suppose I have an equation, and I know that my slope is -3, and the point that it passes through is -1, 7. So I'm going to just pull my slope out of here. I know that my slope, because I was given a slope of -3, my slope is -3. The point it passes through is -1, 7. Now I'm thinking back to what we learned yesterday and how I use those values in the equation. And we know not to freak out about those little sub numbers, x1 and y1. We know that those are just points. So when I think about what that really means, here we go. There's my x1 value, and there's my y1 value. It's just saying given any point, any one set of points. So now let's see if we can plug these numbers in to write our equation. We know that the equation is always going to be in this form. Y minus blank is equal to m, that's our slope, times the quantity of x minus blank, right? This is our form in our linear equation in point-slope form. Now all I need to do is plug in a whole bunch of numbers. I know that my slope value is going to go in this spot, so I'm going to fill this in with a -3. I know that the 2 point values are going to go here in these two spots. So the x value is going to go here, y minus -1, and I'm going to leave it as a -1 for now, just so that we completely understand why the equation turns out to be the way that it does. And for my y value, y minus 7. So when I look through this and I think about what is this going to look like in point-slope form, here's what I've got. Y minus 7 is equal to -3 times the quantity of, look at that x minus -1, that's y. We write the equation as x plus 1. So we use the slope, we use the points, there's our equation. Let's try another. Now I see that I'm going to write an equation for a line that has a slope of 2/5 and a point of 10, -8. Slope 2/5, point 10, -8. I know I'm going to be filling in the blanks for y minus blank is equal to blank times the quantity of x minus blank. And I don't know that you guys are always going to need to do this whole like blank thing. You're probably eventually, and probably actually very soon, going to just be able to fill in your values. I know that my slope is 2/5. I know that my y value there is a -8, and my x value here is a 10. And so when I write this in, I've got y plus 8 is equal to 2/5 times the quantity of x minus 10. And I'm going to leave it just like that, because now my equation is in point-slope form. I'll be honest with you, if you are really ready for this, and this is fine, I'm totally fine with you just going, okay, I got this. I know where the x and the y values go. I know if it's a negative, I'm going to put a plus. If it's a positive, I'm going to put a minus. So I'm totally fine with you jumping straight to y plus 8 is equal to 2/5 times the quantity of x minus 10. Eventually, we're all going to be able to do this without having to fill in the blanks. But I think the blanks are an easy way for us to really understand when it's going to be, like in this situation, a positive and when it's a negative. Okay? So the first part of your work for this afternoon is going to be real simple. You're just going to be writing equations. All right, part 2. Using 2 points to write an equation. I think it's really important for us to remember how to find the slope of a line. And I know that we're doing this in a number of different ways. To find the slope, whichever method we're using, we know that we're finding our change in our y value. Some of us are setting it up as a table. Some of us are just literally subtracting the second y minus the first y, putting that over our change in x. We should kind of be pros at this, at this point. So we're going to start with this. The first part of the question is to find the slope of a line that passes through these 2 points. Totally fine with me if you want to set these up like a table, or if you want to set it up using that formula y2 minus y1 over x2 minus x1. It doesn't matter to me because the cool thing is that we all end up in the same place. I know that a change from 2 to 8 is 6, and my change from 3 to 5 is up 2, which means my change in y is 6, my change in x is 2. 6 over 2 gives us a slope of 3. And if you're doing it this way, real simple, 8 minus 2 obviously is 6, 5 minus 3 is 2. Either way you're doing this, it doesn't really matter to me. Let's just make sure you're doing it in a way that you feel comfortable. Now that I have the slope of my line, right? Slope of the line is 3. Now what I'm going to do is I can use either of the 2 given points, right? I was given this first point, 3, 2. I was given a second point of 5, 8. I can use either point to write the equation in point-slope form. I'm going to do it both ways, but you guys know that all you need to do is choose just one of those points. You don't have to do it both ways, but I'll show you that you can do it either way. So if I know that my point is 3, 2 and my slope is 3, here's what I'm filling in. Y minus my y1 value is 2 is equal to my slope of 3 times the quantity of x minus 3. Let's make sure we understand where that all came from. Okay, so I've got a slope of 3. I've got my slope of 3. There it is. I've got my 2 points. I'll do these in green. My 2 points there and there. Okay? That's it. If you want to use the other point, 5, 8, same deal. Doesn't really matter. We're going to plug in y minus 8 is equal to my slope of 3 times the quantity of x minus 5. Again, here's my slope, and here is my point. Okay? So they look really different from each other, and that's okay. Here's what kind of is a cool thing that's going to happen next. If, and sometimes we'll be asked to do this, if I now take either of those equations and transform them into slope-intercept form, something truly magical happens here, and I want you to watch this. If I use that first point, 3, 2, so I'm going to go and use this equation first. And I take this and I want to transform this into slope-intercept form. Did I do that right? 3x minus 3. Yes. Here's what I got. Y minus 2 is equal to 3x minus 9 plus 2 plus 2. Y equals 3x minus 7. That's my equation in slope-intercept form. Let's see what cool thing happens if I do the same thing if I chose the points 5, 8. So I've got y minus 8 is equal to 3 times the quantity of x minus 5. Y minus 8 is equal to 3x minus 15. Add 8 to both sides. Oh my goodness. Y equals 3x minus 7. How cool! It doesn't matter which point you choose, because when you go and transform it back into slope-intercept form, you will end up with the same equation. Like I said, it's magic. Okay, so let's go through and do one more of these to make sure that we're really truly understanding. So same deal, you're going to be asked to do the same thing. We're going to write an equation for the line in point slope form. So there's point slope form. For the line that passes through, here are your 2 points, negative 1, 4, and 2, 3. So the first thing that we need to do is find the slope. Okay? Again, either way that you want to find slope is fine with me. If you're more comfortable setting it up like it's a table, do it. That's fine. If you would prefer to subtract y2 minus y1 over x2 minus x1, same thing. It doesn't really make a difference to me which way you do it. My change from 4 down to 3 is a negative 1, and from negative 1 up to 2 is 3. So it looks like I've got a slope of negative 1/3. We can kind of double check it here. Change 3 minus 4 is negative 1. 2 plus positive 1. Yeah. So here's my slope. My slope is negative 1/3. Now remember that our second step is we're going to use either point to write the equation. Okay? Use either point to write the equation. So here's what I've got. Okay, I'll do the negative 1/4 in green. So here's what we have. We've got y minus 4 is equal to negative 1/3, right? That's the slope. X plus 1. And I'm going to leave it like that for right now. If I wanted to use the other point, I'll do this in blue, 2, 3. Here's what I've got. Y minus 3 is equal to negative 1/3 times the quantity of x minus 2. So they look very different, but something very cool should happen when we go to transform this in the last step into slope-intercept form. So let me see if I can kind of squeeze this in. My last step obviously would be to transform it, and that would look like y minus 4 is equal to negative 1/3 x plus negative 1/3. I'm going to add 4 to both sides, and here's what I'm left with. Y equals negative 1/3 x, and I've got positive 4 minus 1/3, so I'm going to write that as plus 3 and 2/3. It's okay that that's a mixed number because that would be your y-intercept and not too difficult to find. All right, let's see what happens when I go and transform the next one. Fingers crossed that this works. Y minus 3 is equal to negative 1/3 x. I'm going to change that to plus a negative, plus 2/3. I'm feeling pretty good about this. Add 3 to both sides, and look what we've got. Y equals negative 1/3 x plus, look at that, 3 and 2/3. See? They both end up the same. So here's the point. You can choose either point. It doesn't matter to me which one you choose. You just do one and transform it, okay? You find your slope, you use either point to write it in point slope form, and you transform the one equation you did. I'm just doing it both ways so that you can see that it doesn't matter which point you choose. All right, last but not least, we're going to go on to what happens if we're using a table to write the equation in point slope form. So the only time that I would really think you would need a table for writing the equation is if in the table you don't see a 0 value. If you see on the table, and I'll just jot this, if you see on your table something like 0, 0, you know that that's going to pass through the origin. If on the table you see 0, 2, you know that's going to pass through the y-intercept, right, at 0, 2. If you have a table like this, for example, and you don't know the y-intercept, that's where we would use point slope form. Because I always think about this. If you know the point, and on this table, I know 1, 2, 3, I know 4 points on this table. So if I know a point and I can find the slope, then we should have no trouble using a table to write the equation in point slope form. So what I'm going to do now is find the slope. I'm going to do my change in y over my change in x. A change from 9 down to negative 3 is negative 12. From negative 3 to negative 9 is negative 6. From negative 9 to negative 17 is -8. It's okay that those y values change at a different rate because what you're going to see is my x values from -4 to 2, up 6, from 2 to 5, up 3, from 5 to 9, up 4. When I take any of these values, any pair of my change in y over change in x, here's what you're going to notice. -12 over 6, right? -6 over 3, or -8 over 2. What do you notice? Every single one of these reduce down to a slope of -2. So if I know the slope now, right? I know the slope is -2. I now can write my equation in point slope form using any one of these points. I can use -4, 9. I can use 2, -3. I can use 5, -9. Or I can use 9, -17. I'm going to just choose one point because that's all you guys are going to need to do. I'm going to choose this guy, 2, -3. So I've got my slope. I now have one point, and you guys, you can choose any point you want. And I'm ready to write my equation. My equation in point slope form looks like this. Y plus 3 equals -2 times the quantity of x minus 2. That would be my equation for the one point that I chose. Okay? If I chose any of the other points, the equation's going to look a little different. We're not going to transform these, but if we were, the cool thing is that all 4 of these would transform to the same thing in slope-intercept form. But we're not. We're going to leave it, for now, in point-slope form. All right, 3 different things. Let's kind of go back and make sure we are understanding, okay? 3 different things that we did today. You were able to write equations with the slope and a point. You're able to write equations if I give you 2 points. You're able to write an equation if I give a table. And now you're also able to do a whole lot of transforming back to slope-intercept. Okay, I will let you guys get started on your work now. And that's all I got for you today.